This is Unit 3, Lesson 2, Differentiation by Tables, Graphs, and Symbolically. So this section is about picking a method for calculating derivatives because you're probably going to have to approximate it. You're usually given a table of values but no specific function. So you have to try to figure out which mathematical rule will work to help you get to the derivative and ultimately the slope of the tangent line that you're looking for. For example, the first example says, the table gives the values of a function that is differentiable on the interval 0 to 1. So we're supposed to find f prime of 0.1. So we're going to have to approximate that from what is given. So what we're going to do is we're going to say that the derivative of f at this point, 0.10, is approximately equal to the slope of the line by that point. So we're going to do f of 0.20 minus f of 0.10, and we're going to divide that by 0.2 minus 0.1. So this is approximately equal to, substituting in the values from the table, so we get that this is approximately equal to 0.172 over 0.1, which gives us the approximation of 1.72. Okay, now it's also possible that we can do it symbolically, and we've seen these kinds of tables before, tables that are defined for a function and its derivative at specific values for x. And what we want to find is the derivatives for a function that's made from f and g at the value x equals 2. So we're going to go through these. So I'm going to move this up here a little bit. So the first one, so we can see the table. The first one, h of x, is f of g of x. So this is classically, we're just going to be using the chain rule. So let's write that out first. So h prime of x is going to equal f prime of g of x times g prime of x. So we want h prime of 2. So this is going to be f prime of g of 2 times g prime of 2. And then we're going to substitute those in, so we get h prime of 2 is going to be f prime. So g of 2 is 3, so we're going to have to find f prime of 3. And then g prime of 2 is -1. So this is going to equal f prime of 3 is -2 times -1, so we get 2. Okay, part B says we're going to cube f, so we first want to find the derivative. So k prime of x is going to be, we're going to use the power rule with the chain rule, so we're going to bring the power down, lower the power by 1, and then find the derivative of f. So k prime of 2 is going to equal 3 times f of 2 squared, and then f prime of 2. So we get k prime of 2 is equal to 3 times f of 2 is -4 squared times f prime of 2, which is 8. So k prime of 2 is going to equal 384. Okay, so I would like you guys now at this point to try the last 2 of these problems. So please pause the video, and then I will put the answers here in a second. Okay, so there are the answers for C and D. P prime of 2 is -8, and R prime of 2 is 2/3. So we've looked at a table, two tables, and now let's look at a graph. So what we have is we have a function h that's defined as the composite of f of g of x, and we're given the graphs of f and g. So we're supposed to estimate each derivative and justify our analysis algebraically. So we are going to have to draw some tangent lines here, and I'm hoping that my tangent lines are pretty good, so as accurate as I can get them. Okay, so the first one is g prime of 2. So let's find g. G is the graph with the curves, and f is the graph with the points on it. So let's go to g prime of 2, which is right here. Let's see if I can get that to right here. Okay. So that point is I'm sorry, g prime of 3. G prime of 3, which is that point right there, which I'm going to call 3, 5. And so I'm going to draw a tangent line along here, like that. And the other point that I used was 5, 4. So like right here. That's going to be the other point I used, 5, 4. So I'm going to find the slope of that tangent line. So g prime of 3 is going to be approximately equal to 5 minus 4 over 3 minus 5. So I get -1/2. Okay, so I'm going to erase that on the graph so my graph doesn't get too crazy. And the next one that I am going to do is f prime of g of 3. So the first thing we have to find is, what is g of 3? So g of 3, we already know, is 5. So that was that point we had before. So 5. So we're really looking for f prime of 5. So let's go to 5, find it on the f graph. Right there is, so this point is 5, 6. And hopefully most of you have noticed at this point that we're at a cusp. So f prime of 5 does not exist because it's a corner or a cusp. We have a sharp turn there, so that derivative doesn't even exist. Okay, so next one. Is going to be h prime of 3. Now h is f of g of x. So we are looking for h prime of 3 is going to be f prime of g of 3 times g prime of 3. Well, the nice thing is for part A, we already have g prime of 3. So, and we know that the point, let me write this here because we keep reusing it. The point we're using for g is 3, 5. So this is a point on the g graph. So we're really looking for h prime of 3 as being f prime of 5 times -1/2. But that does not exist. So therefore, h prime of 3 does not exist. So we're going to say that then. So we're going to say, but h prime of 5 does not exist. Therefore, h prime of 3 does not exist. Okay, the next one, f prime of 7. So f prime of 7. So let's find that point on the graph, and we're going to do this one if it's not on one of the corners of f, just like we did part A. So f prime of 7. So let's find f of 7. Here's 7 right there is the point we're looking for. And that point is 7, 5. And the nice thing is it's on a straight line. So I'm going to use a point that I used already because it is on the same line, which is 5, 6. So I'm going to use that as my 2 points for my slope. So let's go ahead and do that. So f prime of 7 is approximately equal to 6 minus 5 over 5 minus 7. So I get, let me put approximately negative 1/2 again. Okay, the next one is g prime of f of 7. So we know what f of 7 is. F of 7 is 5. So we're really looking for g prime of 5. So we're going to use the same idea. Now g, we'll probably have to draw a tangent line because we're on a curve and not on connected lines. So g of 5 is right here. So it's about, I guess, about, let's call it 3.5. So this point is 5, 3.5. Let me get rid of these other points here so they're not distracting. I can draw this a little bigger. So here we are, 5. So we're right there. So this is 5, 3.5. Okay, so if we draw a tangent line along here, when I did this, I used this point right there, which is 7, 2 for my other point. So g prime of 5 is going to be approximately equal to 3.5 minus 2 over 5 minus 7. So I get 1.5 over negative 2. And if I write this as a fraction, this is 3/2 over negative 2. So g prime of 5 is approximately equal to negative 3/4. Okay, and then finally the last one. So we're doing h prime of 7. So that's going to be a composite function. So let's write out what the derivative would look like using our chain rule. So h prime of 7 is going to be f prime of g of 7 times g prime of 7. And so we're going to have to find both of those on our graph. Okay, so this is going to give us h prime of 7 is going to be f prime of, so we have to find where g of 7 is on the graph, so let's do that. G of 7, so if I go to the graph, g of 7 is right there. Can't really call that a half, so we'll call this 7, 2.8. So I have to go to f at about at 2.8. So 2.8 is like right there. So the nice thing is that I'm along this line of f, so I can use this point, which is 0, 8, and the point at the bottom, which is 3, 2. So just getting a little ahead of myself there, but just so we know where we are. So this is going to be f prime of 2.8 times g prime of 7. Okay, and so I'm going to have to do these little slope formulas in here. Okay, so I have f figured out. So I'm going to do 8 minus 2 over 0 minus 3. So let me do that one first. So here I'm going to have 8 minus 2 over 0 minus 3 for those 2 points that I marked on the graph. Whoops. So there's my 8 minus 2, 0 minus 3. Okay, now I have to draw a tangent line, and let me move this point out of the way here. Let me move it up here a little bit more because I'm going to go right through it for the tangent line. So for 7, 2.8, if I draw the tangent line here, not the best tangent line, I'm going to use this point right there, which is 1, 1. So my 2 points are going to be, I can actually use this point because it's on the line and it's not a decimal. And since I don't have a calculator, so that point is 8, 3. So I'll use that. So I'll do 3 minus 1, and then 8 minus 1 for that one, because that's right on the line. Because remember, we're approximating, so I can be a little generous with that, and my line's not the best line on my stylus. Okay, so this is going to be 3 minus 1 over 8 minus 1. So we're going to get 6 over negative 3, which is negative 2, times 2 over 7. So we're going to get negative 4/7. And that ends the lesson, and we'll be working on these in class tomorrow.